My name is Connor Pike, and I'm going to be a co-host for this podcast, and I'm a writer for Siemens Digital Industry Software's Thought Leadership Team.
And I'm Dale Tutt, Vice President of the Industry Strategy Team at Siemens Digital Industry Software.
Hi, I'm Nand Kochhar, Vice President of Automotive and Transportation Industry with Siemens.
So in a new series of podcasts, Dale and I are going to be joined by some seasoned experts from around Siemens, and we're going to be discussing the trends, technologies, and opportunities affecting some of the largest and most important industries in the world. So today we are joined by Nand Kochhar, who already very helpfully introduced himself. As he said, he's the Vice President of Automotive and Transportation Industries. We're going to talk with Nand today about the future of the automotive industry and transportation more broadly. And that's going to include this really important key trend, which is moving towards vehicle autonomy. So Nand, welcome. Thanks for joining us today. And I think just to get started, we'd like to just get a brief introduction from you, some of your background and what you do here at Siemens as well.
Thank you, Connor. Thanks for the kind introduction. Once again, my name is Nand Kochhar. I'm Vice President for Automotive and Transportation Industry at Siemens Digital Industry Software. I joined the company in 2020 after nearly 30 years with Ford Motor Company, working in several technology areas. At Siemens, my key responsibility is industry strategy, which you can classify as two-pronged approach. One, coming up with a go-to-market strategy. The second is driving what we call inbound processes, developing our solutions for our customers to implement.
One other thing I feel that we've talked about in the past is you had this some involvement in an SAE council for vehicle autonomy. Could you talk about that a little bit?
While at Ford, I also served Society of Automotive Engineers in several different capacities. One of them was as the chairman of Automotive Council, where back in the day, the autonomy wasn't well defined. And even in the US, NHTSA was looking at what's the common definitions of levels of autonomy. So one of the things I can always remember and think of is, as a part of associated with the SAE, we introduced the levels of autonomy, what is very well known today in the industry, SAE level 1 to 5, which defines different levels of maturity and automation in the vehicles. That came out of SAE, and of course, NHTSA adapted the same definition, and the industry is now talking the same definition while deploying those technologies.
That's awesome. So I think it's clear, Nand, that you're a true expert in this field, and especially given your long experience in the industry. So I think to start our discussion today, I want to get your opinion on the kind of rapid technology advancement that I think we've seen in the industry within the last decade. So is it fair to say that there's been this rapid increase in the technological complexity or sophistication in the industry?
Yes, it definitely has. Also, it's coming from a lot of advances in the computing technologies and artificial intelligence and machine learning has enabled cross industries, and especially in automotive, to bring in the new technology. Let me use a few examples. Electrification. It's most likely on top of everyone's mind, and you hear quite a bit in the media. And that is the biggest change going through the automotive and transportation industry, driven by a lot of reasons, both from a consumer trend standpoint and overall sustainability and overall objectives, what customers want. So within electrification, there are several factors. And as I said, automotive is more than 100-year-old industry. It has not seen this level of change. So you're replacing your traditional gasoline or diesel engines, powertrains with battery as a source of power. And that causes the rest of the components within the automobile to change, whether it's the e-powertrains, whether it's all the other things which need to happen. So using an example of an electric vehicle, now you have to do the battery management system. So you have a very high extensive use of electronics and software to manage not only the battery, but the entire vehicle. So you see all of a sudden, you've got electrical electronics, battery technologies, as well as the software all coming together. And they influence the rest of the things like the driving dynamics and the vehicle performance. I always find it very interesting. Working for most of my career in the automotive industry, we always had to find how do we fix noise, vibration, and harshness problems because customers don't like noise. And now coming to electric vehicles, the problem has become the other way around, that the vehicle is too quiet. So then we had to work on how do we introduce noise so that the pedestrian know and the consumer gets a feedback the car is running. So you see, it's kind of very subtle, but from a technology standpoint, these are the kind of shifts happening in the same old automobile, but underneath it's becoming a lot of change.
Nand, do you want to talk a little bit more about the autonomy? I think that's one of the other changes that we're seeing so much about. And we hear about all these different levels of autonomy. Can you give a summary of the levels of autonomy you're referring to and how that's changing within the industry? What in particular distinguishes these levels of autonomy from what's available today with some of the systems out there?
So the level 0, so to say, is where there's no automation. Then it starts to build up from there, level 1 and 2, going up to level 3, and then I'll separate out level 4 and 5. So level 1, the good analogy is that some function of the car, whether it could be the linear motion of the car, that is controlled by software or some level of automation. So a good example would be that braking systems are contributing towards adaptive cruise control. This is the level 1. You're bringing in one feature of function. Then build into level 2, where you have a now combination of things like getting the steering control as well as the braking control that the car is able to maneuver, offering features for customers like lane keep assistant, lane departure warning. So that's the level 2, that you're increasing the levels of automation in a vehicle. And I always talk about cars, but it could be trucks, it could be any other transportation modes across industries as well. And then when you get into level 3, now you introduce on top of those two things, additional the mapping functions and the vision systems to a level that you can pretty much say the car is driving on its own. However, it does not have a lot of the fail-safe system and the other technologies. So it becomes that in case it's needed, there'll be a warning system and the driver in this case is still needed and you have to take control of the vehicle. So level 2 and 3 are already out there in the marketplace for the last few years. Most of us might be driving newer cars and you'll see an example where you get a warning signal, keep your hands on the steering wheel, as an example, for a few seconds. And different companies adapt these in different ways. They let you drive without any holding of the steering wheel, but after that, they'll say, put your hands back on the wheel. So that's the level 2 and 3. Level 4 is where you could say of autonomy, where the human driver is being replaced by the computer driver. So in this case, the reason it's level 4, because you're still putting it under some kind of geofencing conditions or some conditional. It could be that you can drive this in certain portion of the highway only. It could be the shuttles driving in a campus on a university. It's the mapping area or where things are going and the surroundings are well defined, and that's level 4. And the level 5 is the ultimate level of autonomy where all of those constraints have been limited. So in other words, you could driving any weather conditions, every vision conditions, and different terrains as well. So that's the extreme level, ultimate level of autonomy. But with level 4, you will see, the commercial things like the trucking industry might use that to an extent. You also see in certain cities, you'll have shuttle services as an example, or robo-taxis. And those are the applications which you, in fact, already starting to see on the public roads in different parts of the world.
It's very cool stuff that we're seeing right now. And when you start to see some of those vehicles hitting the road, it's definitely going to change things. And that's a great summary of the different levels of autonomy. And what I find interesting is the journey towards autonomy has been a little different for different industries as well. And talk about aerospace in a second, which I have a lot of experience with, but like in industrial machinery and in the industrial settings, you're seeing more of these automated guided vehicles that help deliver material and parts around manufacturing facility. And at some level, they had some levels of controls in the past, but now they're being allowed to operate more autonomously, but really within a very constricted space, as you said, maybe like level 4, as you were just mentioning. And trucking, which you did highlight, that I can see in that kind of environment where moving around in a city condition where there's different scenarios as different than, say, when you're on a long journey across some of these highways as you're just, going across the country. And so it may be easier that you can more easily automate some of those than in other settings. But in aerospace, as you were working through level 1, 2, 3, 4, and 5, I kind of thought back to some of the journey that I've seen in that area where the first steps around automation were really automating functions in the cockpit and with the goal of reducing burdens on the pilots. And so it might include, automation of how do you make changes to the flight path, or how does the aircraft itself respond to certain systems, the way the information is presented to the pilots, the navigation, for example. The change that you saw was back in the 60s and 70s. It was not uncommon that these large commercial airliners would have 3 pilots on board. So you'd have your pilot, co-pilot, and a navigator. And then as they started to automate some of these functions in the cockpit, and then they went to 2 pilots. And now you're starting to see this discussion where, especially with future and this anticipation of pilot shortages, that more automation would maybe now you'd come down to 1 pilot in the cockpits as you start to automate some of these functions. So it's interesting to watch. And then the first step of what people maybe perceive as autonomous operations, there's these unpiloted vehicles. But what is actually seeing is, that they're piloted, but maybe by somebody that's 1,000 miles away, or even, half a world away. They're maybe flying 5 or 6 aircraft simultaneously. So there's some level of autonomous operations within a certain space, but they're still being managed and monitored by a pilot. So kind of like what you were saying with your level 3 car that'll prompt you, hey, it's time to take control and do something here. But ultimately, there's still a human that's controlling it. But now as you start to see aircraft in these true autonomous situations, or these air taxis, drones that, that can fly over short distances, you see, like, in some cases, they're within a very constrained area. So like delivery drones that they talk about, okay, they can only fly a certain altitude off the ground, and they fly within a certain airspace and only so far away from the delivery truck. But then in the future, you'll start to see these air taxis that will be truly autonomous, and they will, be able to fly all over a city and within, again, maybe within some certain constraints. But it's really interesting to see the similarities between these different industries and what you've described with the automotive industry and just general acceptance of autonomous operations.
Yeah, well, you're absolutely right. The cross industries, some of the technology is same, and the applications vary a little bit. Very good analogy on how you describe the cockpit feature function delivery and begin with. So in auto industry, again, autonomy just didn't pop up all of a sudden. While we are talking about autonomous cars, within chassis controls, we worked on features like self-parking. That was done many years ago, and that's an example where this automation was being introduced. As you know, in a lot of cities, the parking spaces are really tight. Having that feature function was very successful by some of the automotive for their customers, that in a very tight space, vehicle is able to measure and self-parks. Obviously, that's at least level 2 because that includes the steering function as well as the braking function. And then it builds on from there. Then it moves on into, as the LiDAR, radar, and camera, the vision systems continue to improve, and the mapping conditions coming from either from the cloud or within the vehicle, you start to see these things migrating. Again, very common, as you said, across industry things. One of the things for level 4 we call the geofencing is remote monitoring. That's one of the scenarios. Very similar to, as you said, a 5 or 6 plane being driven by or controlled by the same person. The fleet example I used in the campuses could be, again, there's a remote monitoring, and it's being controlled from a control tower. That's, again, we call it a level 4 because now you put some kind of a constraint on it. You're not letting it go all the way. So absolutely correct that a lot of commonality across industries.
What's interesting to me is, as we've been talking about this, we've already mentioned things like advanced computer chips and mapping technologies, and then obviously also kind of some smart infrastructure type of things. For companies who are trying to develop these vehicles, they have to operate it across this huge range of scales, from like the nanometer sized devices on a chip all the way up to this kind of kilometers of a city. So how do companies push that technology forward across this huge range of scales and technologies?
Very interesting question. So, this leads me towards that by introducing these feature functions, the complexity continues to increase. How companies adapt this is by adapting overall digitalization, and within that also applying systems engineering approach to solve these problems. So you define your ecosystem and then you approach your target setting, cascaded, etc., based on what your problem you're trying to solve. When you chunk that out, you can separate out local functions at electrical electronics, let's say the chip design level, and then you build those into the next level of subsystem, and which builds into the full vehicle level systems. And that's how you approach chunking the problem one at a time, but at the same time integrating and feeding into each other in a systems engineering approach. A very good example of that is traditionally we've been designing cars, as I said, for many years, many decades. We looked at car as a system, and then you divvy up car into a body system, chassis system, powertrain system, electrical electronics, etc. But the focus was always delivering a car in this example. Followed systems engineering approach, you did what we call traditional PLM, that you applied all these technologies, but the end goal was how to design, develop, and deliver and manufacture and deliver this product called car. Now autonomy comes into play. All of a sudden, your system definition has changed. This car needs to operate in a city. Since it's running in an autonomous fashion, car needs to talk to other vehicles on the ground. Car needs to also sense the infrastructure, whether it could be a traffic lighting system. So all of a sudden, you see your system definition has gone much broader than the car itself. And now you have to take into account all these other factors and you need to approach. And this is where you could see all multiple technologies, not only electrical electronics, but also the telecom industry, the infrastructure, all that have to come together and play together in order to deliver a holistic experience for our customers driving an autonomous vehicle in a safe manner.
I'll build on that word safety. It's, as I think about these with the autonomy and whether it's, an air taxi or an autonomous taxi, one of the challenges for these companies is how, as they develop these autonomous cars or vehicles, these trucks, aircraft, is how do you build that trust with the public? If they don't feel safe or if they don't feel confident that that car is going to get them where they want to go, then the adoption of this will stall. It'll get limited adoption in some areas, but it may not get general adoption among all of the public. And having more exposure to this in time is certainly one avenue. But, anytime you hear if there's a problem with an autonomous car, it will make the news. And so what can companies do to build that trust in addition to just all of the engineering work that they have to do to build and test and verify these cars and these vehicles?
Very good question. It's just like trust is the biggest thing. And a lot of companies put that in the middle. How do we deliver? How do we get? So this is where it's not only about technology. This is about policymakers and the educators come into play. And these things happen over a period of time. That's where the pilots of running shuttles by companies like Waymo, let's say, is an example of they're getting a smaller group of people who are getting comfortable with this. It will mature over a period of time that the general public is starting to trust in these. On the technical side, technologies will continue to mature, and also at the same time, standards organization will start coming out. Believe it or not, today there's no set standard of how do you test and validate an autonomous vehicle. They're still in evolution. As they come in and the policymakers come into play and deciding some of these factors, that will deliver the confidence. And after that, you have things like in several different countries have different mechanisms. We have AAA, Safe Driver Program, which teaches kids or the early adopters of the technologies to drive some things. There will be a lot of those type of actions. I always use the analogy, since I've worked in the safety, crash safety for many years. When the airbags were introduced, it was the same thing the customers went through, that industry introduced airbags as a safety feature, but still the customer had to go over it because in the initial stages of it, sometimes airbags didn't deploy it right and did hurt the customers. And it started to create an impression, is that something good for the customer? So industry had to do a lot of education, a lot of technology maturity. And today people don't even think about the things like seatbelt pretensioners and the safety airbags they operate in the vehicles. Same thing in overall full vehicle technologies. It's not just all of a sudden things are going to become autonomous. Adaptive cruise control has been out there. And over a period of time, there's several surveys which show that people are starting to get comfortable with some of these feature functions, which are part of that automation. That's what's going to drive the shift and the change.
Sounds like a big part of that is people just getting comfortable with the technology. I know some people who, even though backup cameras, for example, are getting more and more common, I know some people who still don't have one on their car. And so then I've had people tell me that they don't feel confident in the backup camera, which to me is a little surprising because it is just a camera. But if you're not used to using it, I think, it can be difficult to get on board with something that you're just not familiar with.
It's a combination of things, right? You have to get used to it, these features. And then we also know from the past experience on some of these technologies, not everyone, there's a demographics as well. Not everyone gets comfortable with everything, and they all are in a different path. How long it takes for that group to migrate versus the other. So all those aspects are part of it. Backup camera is a good example. And camera itself, whether you need radar, LiDAR, and camera or just camera is good enough, will drive some of these changes from a technology perspective as well.
So I think at this point, we've done a good job of covering that technology side. But I think another important thing is, what is the commercial or the business side to this question of autonomy? What is driving companies to invest money and time in developing these things? And what are the opportunities that they see?
There's technology is one thing. From R&D perspective, every company looks into that, but there's a business driver. So there are several business drivers, both on electrification as well as on autonomy. The autonomy, I would say the biggest driver for adopting is, in theory, it will make vehicles safer if it performs better than what a normal human being does as a driver, because now it is controlled all the time, and there's a lot of artificial intelligence built into the virtual driver, and continuous learning of the virtual driver will end up making vehicles safer. That's one. But that's not directly very commercial. On the commercial side, you can use several examples. Let's use one from the trucking industry. We all know there's a huge shortage in the trucking industry for drivers. So a level 4 or a level 5 coming into the trucking industry will be a huge business success for the trucking companies. Let's take a look at all the fleet, whether it's Uber or Lyft. Today, cost per mile, what it takes versus owning a vehicle, one of the biggest factor in there is the human driver cost. So now if you have a robo fleet, you've taken the biggest cost element, and all of a sudden it's a very profitable business. So that's why you see within the industry, it's not only automotive OEMs, but also a lot of the fleet companies investing in autonomy, all of the technology companies investing in autonomy because they see a new business model. And traditional OEMs want to jump on this from the other angle, that they can produce vehicles, but at the same time, they're creating new business models for themselves, and they're generating new revenues by doing things of that nature. So you see there's a business case, multiple different angles. That's how the new businesses are being developed around the autonomy.
And I think there's a sustainability and benefit to autonomous vehicles as well. It's whether you're talking about a family vehicle or semi-trucks or taxis or these fleets of vehicles, it's, as Nand said, there's a strong business case with many of these fleet operators. And think about these large cities where there's just a tremendous number of drivers, just taxi drivers and stuff. And it does give access to people that think about just the time involved when I'm driving. when I used to live, like drive out in California, and I'd spend, several hours on the road, and that was time that I wasn't doing something else. And so then you can talk to the sustainability aspects, that when you're on the road, that there's opportunities when you start to make the cars more harmonized in how they're operated and how they're controlled, that you might actually be able to reduce the traffic constraints and improve overall fuel economy of some of these vehicles. And especially if they're electric, they still use less energy, and less energy is a good thing. And so I think, you can, when you think about like these large freeway systems in some of these large urban areas, if one car taps his brake lights, you see this, this wave effect for miles back, where all the cars start slowing down, and you all of a sudden you're going 10 miles an hour, and pretty soon you're going 70 again, and you're like, what just happened here? You can actually see that the roads would be, maybe a little bit smoother, and you wouldn't see some of the traffic delays that you see in some of these large cities, even with the same number of cars on the road. And so, it can really increase the efficiency of all these delivery systems, the package delivery systems like Amazon and FedEx that are, delivering packages. You reduce emissions. And again, we're talking a lot about electric cars and electric vehicles. And so there's a natural tendency to assume that you reduce the emissions just because you're not burning carbon. But if you can still reduce the amount of energy you used, as I mentioned earlier, that's energy, that's electricity that doesn't have to be produced somewhere else and then be used to charge a car. So energy efficiency is always going to be king for all of these vehicles. And so I just think there's a lot of opportunities that as we start to see more autonomous vehicles, it's going to really change the way we move about these large urban areas in a much more efficient and productive manner.
Yeah, again, Dale's absolutely right. Electrification is, you could say, pretty much directly tied to sustainability. Most of the autonomous vehicles might be electric, so you see a big sustainability angle. But my favorite one is another one, the freedom. It's a freedom of many levels. We all, as human beings, at some point get in that we're not able to drive. Whatever the reasons might be, it could be simple aging, or it could be some other constraints that people are not able to enjoy driving today. So if they have an autonomous vehicle, it offers a great opportunity and offers freedom to anyone to go from point A to point B. And that's, I think, to me, that's one of the most important things. Same thing as a growing families, once the trust is built, just imagine, you don't have to take your kids around all the time, that they can rely, or you could rely on this. And what kind of freedom it'll offer to the families, what kind of freedom it'll offer to human beings, that will come. And I don't know exactly the time frame. No one has a crystal ball. But having seen the technology maturing for the last 30 years, I think over the next few decades, we're going to starting to see this just technology changing the landscape, and autonomous and electric vehicles are going to be a big part of it. It's going to change the lifestyles of people all over the globe.
You talk about freedom, and I was thinking about one funny thought that, one of the things that we always enjoy the freedom of is when we get to drive our own cars, and actually, maybe some people have a sports car and want to go as fast as they want. And now will the cars all be programmed to go the same speed, or will you still be able to program it to go faster? So anyway.
Yeah, no, that's, I think in the industry, we debated this point, because most of the auto executives, while we are working on autonomous vehicles, had that thing. Hey, I joined this industry because I wanted to have fun. Yeah. Like we drove around Mustangs like crazy. That's the fun part. It's fun to drive car. That's why I use the examples of who might use autonomy is who needs it. And that's why we always left that option of fun to drive aspect of the cars always needs to be left there. It's just like from a design standpoint and styling standpoint, they need to be attractive. So when you see on the road, it needs to develop a feeling that I want that product, right? So that doesn't go away with autonomy. Same thing as fun to drive aspect doesn't go, but at the same time, it opens the door. Your example is right on. I know you lived in California, so sitting in LA on a 405, in a traffic all day long, or maybe many hours of the day, if you're in an autonomous car, you could be doing whatever you need to do, catch up on sleep or catch up on reading. At that point, you're not into a fun to drive mode. And over the weekend, you go where our canyons are, right? Yep. Right by Malibu, and you want to drive. So you switch the mode. Yeah. And you see, this is again, It's not a pipe dream. It's already out there. We know from Tesla as an example, because of heavy reliance on software and electronics in the car, these feature functions are being sold with over-the-air update. So you can buy driving modes when you need them. Your car upgrades. So look at this, how smart that is. It has created a revenue model. Everything is being done over-the-air software update, and you're getting new feature function to try. And when you're done with it, you move on. You're not paying for it all the time either. So I think the industry is adapting, again, especially in the electrification. Here's the hardware piece, and here's the overlaying, the software and the technology piece on top of it. And that way you will see that you'll have a platform and the hardware common for a long time, but you'll have fresh products, new feature functions many more times, maybe not as frequent as the iPhone update, but not as big as waiting for 5 years for a car model to update. So you see there's so many these new things pop up with technology that we didn't imagine, or we just imagined and couldn't deliver a few years ago.
Hopefully that can extend the life of the hardware too. I mean, we talk about the sustainability aspect. If you're bringing out new software updates or features via software, then maybe the physical product can still feel fresh and exciting for a longer period of time for people. So instead of getting a new car every 5 years or whatever, you might hold on to it for a bit longer. And that's another benefit to, reducing consumption of materials and energy and all those things. So it's a really interesting point.
Definitely. I mean, today you have to recycle and it's a huge, from a sustainability point of view, huge burden today, right? All that is becoming a natural part of sustainable and agile product developments within the automotive industry. And industry is already thinking about those things, all these angles, while delivering autonomous vehicles.
So, guys, thank you so much for jumping on to chat with us today. I think before we wrap up, I'd like to give you guys both the opportunity to offer any last thoughts or any questions, Dale, you might have for Nand, or vice versa.
I've really enjoyed being here today, and thank you, Connor, for inviting us and hosting us in this. And I think I'm just struck by, as we've talked through the development of the autonomous vehicles, is how much it's transforming our companies, our culture, really from producing vehicles to really producing mobility services. And you're seeing the same thing in aerospace. You're seeing the same thing in heavy equipment, where they're transforming some of those industries as well. So it's amazing to watch that transformation that's going on and how it's changing how people work, how the engineers work to design, develop, and certify or verify these new products, and then how you're going to build those products. We're seeing changes in how it works and how people are having, companies are having to adopt digital transformation to actually accomplish that. And so I think that's the thing that I'm most, interested in, that we're seeing so much change, so much transformation, and how we're enabling these companies, these people, to really change the world for good as we go forward and change it to make it better. So again, thank you for having us here today.
Yeah. Thank you, Connor. Once again, I echo everything what Dale said. There's a transportation revolution going on for both the existing as well as the new people, new players coming in. Also moving from a simple automotive industry to becoming a mobility industry is a very key point. Because the new business models are coming. In fact, some of the big names in automotive have renamed their companies to be a mobility company. And what's very interesting thing is as well, the definition of what we have traditionally called aerospace and automotive, those are merging as well with the unmanned vehicles and the drones. When I was in SAE working with them, from a standard standpoint, some of these things are coming together. So you see cross-industry pollination of all these things happening as well. So very exciting times. And again, digitalization is where we come into play, is one of the huge enablers that it can convert all this complexity caused by new technologies into a competitive advantage, because it can help you get through it and also deliver new business models.
Awesome. Well, thank you guys again for joining me today. I think I really enjoyed the chat as well. So thanks as well to our listeners for joining us. And in the coming weeks, Dale and I are going to continue these conversations. We're going to explore more technologies, trends impacting industries, and more. So we look forward to welcoming you back in the future. And until then, see you later.